is Ilari Mikkonen. I work for Controsec. I was a project manager for this project. First and foremost, this session is for you guys. So we are so few here that if you want to express some particular interest that you want to talk about or hear about, just stop me at any point. Let me know. We have reserved some time for questions and answers in the end, so you can use that, or you just stop me at any point. What I'll do is it was a long project, so we did a lot of stuff, more stuff that I will present here. I'll focus on the technical components and on the implementation, but it should be pretty fast paced. And there are a couple of demos that I want to show you guys. So let's start. I'll start sharing the screen. Alrighty. So let's go to the first page. Can you guys see the screen okay? Is it good?
Yes.
All right.
Yes.
Thanks. So today's topic is basically ODALA Smart City Architecture and Deployment. And ODALA stands for Open Data Lake for Cities and Communities. And like I said, it was a long project. There was a lot of stakeholders in it. This is roughly the schedule that we'll be following today. And before I forget it, I'll tell you that this was co-financed by the Connect European facility. So let's not forget about that. We'll talk about the architecture, a little bit about the components, how to deploy things, a couple of lessons learned, and then Q&A. Shortly, what this project was, or this part of the project was that we had several activities in the project, and activity 2, where I was on Controsec, was a lot involved. The objective was to implement data lake in the city of Kiel, including the data marketplace and the security layer, and this is where our focus was. The idea is that we create tools for cities and communities that they can reuse. These components are open source, and we try to pick the architecture in such a manner that it makes sense. We have experience on deploying smart city solutions in different cities, so try to reflect that. Basically, as an outcome of this, we have a running platform for the city of Kiel. Kiel was the front-runner city, and today I'll be using that platform, so I'll demo you a couple of things. This was a 3-year project, a long project with I think that figure is not actually correct. It's 17 different stakeholders. We had a change in the middle, and it was 75% funded. This is how the end architecture looks like. And we had many revisions. We started looking into this architecture at the beginning of the action. And the basis of all this work is basically a grant agreement. So we have this fixed paper that tells that what this project is supposed to do. And there were several things already marked there that what we are supposed to do. And one of those was, for example, using Keyrock and Umbrella to do the security layer. But as you notice, there are also other components. I'll show you a bigger picture so you don't have to zoom. So basically in this access control layer, which is on the right-hand side, we used Keyrock and API Umbrella in the beginning, and then we went to use API 6 and Keycloak though. So there was a lot of changes in that department. But if we look at this architecture as total, you can see that there is sort of like this southbound, northbound thing. So from the bottom, you can take sensor information into the platform, data from the public sources, and then next part, there's this transformation layer. We used Apache NiFi. Cirrus was responsible for that. So for those who are not familiar what Apache NiFi is, it's basically a tool, low-code, no-code tool. You can do easily different data manipulations and things like that. So it's an ETL tool in a way. In the heart of this architecture, we have Scorpio Context Broker. One of the project partners in this project was NEC, who's responsible for the Scorpio Context Broker. So the data was ingested in the Scorpio. We also use Quantum Leap. This is mainly for NGSI v2 compatibility. So some of the cities wanted to still use Quantum Leap and as a database Postgres. That's good. That's a good database that we like to use. Then there are those enabling services. What that means is that so we have ingested all this data into the platform, but you need to present it in one way or the other. And for that, we used Grafana as visualization and analytics tool. This ecosystem is a marketplace basically, and Seekan played quite a big role. It's basically a data publishing tool. And one of the key elements in this project was to get data into EU level. So what we did was we put Seekan, and that data was then available from the city, and that data was then available on national level, and that data was then available on EU level. That was one of the biggest goals of the project, basically. On top of that, initially we had two use cases. So mobility toolkit, NEC was responsible for that one too. The idea is that it's a CO2 calculator, and you can ingest certain data into it, and it gives you all sorts of outputs, CO2 calculation and things like this. Then there was an environmental toolkit that collects sensor data from environmental sources, particulate matter, CO2, temperature, all of these things. And then additionally, we have a trip planner developed by the city of Arezzo, or Atam and Fuchs as the project partners. And it's basically this open trip planner that allows you to plan your trips. I don't know if you're familiar with that, but in Finland, that's actually being used by many, many cities. Then I touched about the access control layer a little bit already. So the brokers, they don't have any access control by themselves. So you need some sort of mechanism on top of that to manage the access. And we developed the security component, which I will demo today. Basically, the idea is that it's a web application firewall. It blocks the attacks into the system and logs them, and you can get alerting from that. Then the final piece was this data spaces. We used IFO-Trust technology for this. It's basically iShare fireware cooperation. It utilizes Kong as a reverse proxy. And we developed a couple of UIs as a proof of concept UIs so that we can make things work. Then there's supporting infrastructure described on the left-hand side. You can see the Kubernetes icon over there. So we were using Kubernetes. We were using GitLab as a CI/CD pipeline, and some metrics and analytics. Like I said, the architecture was iterated in a couple of phases, and this one was the first one. We used the umbrella key-rock combination over there. We had Quantum Leap, everything rests on Postgres timescale basically, and then NiFi integrations. And then the second one, we put more stuff. So basically the IFO-Trust data spaces layer, marketplace replaced, even though the umbrella key rock based solution is still available, but everything should now go via API 6 and Keycloak. Well, try to make it better. And as said, everything is open source in GitHub. So we'll return to that a little bit later. I can show you that, guys. A few words about the component choices. One of the fundamentals in this project, as mentioned in the grant agreement, is the use of NGSI. Basically, that means that we needed a context broker. And because NEC was there, Scorpio was a pretty easy choice. There are other brokers also available, and I know that a lot of smart city deployments, they still use Orion as a context broker. But I think using the LD was a good choice for this. Grant agreement also dictated some of the other component choices like CCAN and access control layer. But we were able to stretch the budget, so to speak. So in my personal opinion, we managed the budget pretty well. We had activities when we saw that we don't need to put so much effort in certain activity. We took money from that and put it into other places where it was better used. And the City of Kiel as a coordinator played a big role in there, also the technical working group. And there's a quotation from the grant agreement. So the object make new datasets available through EU portal by leveraging the existing use of technologies and the context broker and the protocols, basically. Okay, I already talked about this. So NEC Scorpio broker, it's a good broker. It combines if you are familiar with the Orion context broker and the context broker concept in itself, Orion doesn't do historical data. And Scorpio does historical data. In Scorpio, it's called temporal entities. In the past, the one alternative that we had been used is a Orion context broker plus Quantum Leap. Quantum Leap offers that historical data API over Postgres database. It's a reasonable choice, but that architecture has its drawbacks, basically. One of the major things is that you have to take the data from the Orion context broker and put it to Quantum Leap. And the only way to do reasonably that is over HTTP and REST API. And the drawback of that is that it's basically asynchronous. And if you lose data, you might know that you lose data in between, but you don't know what was lost. So that's not easy to track. And you have to build some sort of additional mechanism in that. But in this one, in Scorpio, of course, there can be a database error and stuff like that, but it's an atomic operation. So you ingest the data, you put it in the database, and you're done. So that was a fairly easy choice. At that time, the other alternatives was Orion LD. And I can't remember if we considered anything else at the time. This is already years ago. So there has been now other brokers also in the market, but at the time, that was not possible. About the access control layer, easy choices. First iteration, Umbrella and Keyrock. We have been using Umbrella quite a lot earlier, and also Keyrock. Umbrella is, in the beginning, it's an American project. It's an open source project, but due to some budget restrictions and changes in policies, they were not able to really maintain the component. So NREL is a National Renewable Energy Laboratory from USA, and they had certain open source projects, but they had to cut down some of the support for that. And then basically the community took Umbrella into its arms and was trying to maintain it. It ended up then in Fireware's lab, and Fireware was maintaining it, but then also Fireware announced that, okay, they cannot do support for Umbrella. Keyrock, a little bit similar story. Keyrock has better support. It's still used in this IFA-Trust project, but there are sort of like no commercial support and there are no guarantees. Once we noticed this during the project execution, we decided that, okay, we have to do something about that. We cannot run production grade platform with components that have questionable support. Then we did investigation that what could be a good choice. And Keycloak was fairly easy. It's a lot of used IDM solution, and it was like a kind of like de facto. A lot of deployments use that. For the reverse proxy, we were comparing Kong and API6. They are very similar in a way, and in the architecture you see them both. They are both Nginx based. They are both cloud native. They both have plugin architecture in it. So we still decided to use the API6 for the access control layer, partially because we were more familiar with that. And Kong is then used in this databases business. Just briefly about the managed Kubernetes cluster, the keyword here being managed, so we didn't manage it. The city of Kiel made a tendering process and they tendered for managed Kubernetes, but it has a multi-controller setup for worker nodes. It's managed Postgres cluster with RUKSEF as a disk, or what is that, storage solution. Then a few highlights about the components. Before we run into that, is there any questions? Because if you have anything, I'd love to hear it. I'm not following the chat, so if you're typing something in there, I can't see it right now. All right. If you change your mind, let me know. Let's move on. I already touched upon this, the Scorpio. So it's an NGSI LD broker, so LD is linked data. It allows you to do linking. It has new features over the V2 Scorpio. Scorpio context broker in itself has interesting native capabilities. Temporal queries, it's pretty cool. You can just put the temporal into the URL, put in few parameters, and you get answers from the broker. Of course, it has a subscription system like all the other brokers. But then during the project, we experimented quite a lot with this federation aspect. So federation means that when you have a main broker, it can have federated setup. So there are brokers under it connected to the main broker. And when you ask the main broker a question, it has knowledge that this information might reside on the child brokers, and it then queries the child brokers and compiles the result and gives you the compiled result together. Now, the security component. This is something that we developed. It's a web application firewall. And actually, let's do a demo. I'll show you guys. And I'll explain along the way that what are we really up to. There's a question, so I'll read this. Context and temporal data. It's basically Postgres. And the PEP proxy, like I said, API6 and Kong. And that's still the same answer. So, for example, in the city of Kiel, both of them are running. The API6 and Keycloak solution, it's like a standalone solution. So it has no data space connectivity in it. But the data spaces then use Kong. And the reason why they chose Kong is that plugin architecture, it has great commercial support. And they only had to do the plugin basically for that. So that was the rationale over there. We don't exactly see eye to eye on some aspects. That's why we used API6. One of the things is that Kong is not 100% free. Some of the things there cost money. It's okay for things to cost money. I'm not against that, but we also wanted to provide, in a way, totally free alternative, which is then API6. But okay, let's take a look at that. So the security dashboard. Let's do a deep dive. This is how it looks like. And what it does, it sits in the ingress controller of the Kubernetes cluster. And the idea is that all the outside communication goes through the ingress controller. So all the requests come through there. The security rules themselves can be set for each individual component. And once that has been set up, when a request comes, it's been evaluated and seen that if this matches one of the rules and it exists an anomaly score, if it triggers that score, it will be blocked with forward 3 response, basically telling that, oh no, now you don't get in. And one of the ways to trigger this is to make an attack. So let me just get this. I'll make an attack. What I'm gonna do is I'm trying to run a script, shell shock script in the platform, and I get this 4-3 forbidden. So I'm not allowed to do that. And let's hit it a couple of more times. 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we should see the numbers change here a little bit. This used to be 10, now it's 20. And you can see the IP address is here. This is my IP. This is not me, by the way. And this is some other guy. So the point of the security component is that internet is whatever you have connected to the internet. It doesn't matter what it is. Somebody's trying to probe all the time, whatever ports you have open, and try to do different attacks. The idea of the security component is that you are aware of the attacks. So this makes them visible. This makes them actionable. So you get a source where the attacks are coming from. And what we have developed here is a alerting system that I will show you shortly. So you can get email alerts when something goes massively wrong. So you don't have to guess. System is down. It's really slow. What is going on? I don't know. But if you have this running, you'll get an email alert about that. And as a side note, we are not the only one providing such systems. For example, Microsoft Azure, they have a similar system. Their system costs about anywhere between $200 and $400 per month. Ours is kind of free. So I highly recommend to take a look at this. But yeah, let's go to the alerting rules. Now, here we have other alerts here too, so don't get confused, please. This is now pending because I made attacks. And the rule is that more than 10 attacks from single IP in 10 minutes. Well, I think it's actually 10 attacks. So this is now pending. So it takes a look at the amount of attacks in certain time period, which actually here is now 7. It samples it every minute for 7. Why is it 7? It needs to be less than 10 because it doesn't fit to the bucket. It's one of the Grafana peculiarities. And here we can see that that's not pending. I'll show you the little bit about the rule. So it's sort of like a cascading rule. So these things need to trigger, and we evaluate different expressions. And once those trigger, then basically we get an alert. So in roughly about 8 minutes, I should get an email. I can show that to you guys then. All right, that was the security component. Yeah, the access control, I actually already talked about this. So API 6 and Keycloak, cloud native, good support, plugin architecture, ready for integration. All these new, so the security component and the new access control layer, it's code only configuration from CI/CD. So we don't do any manual configuration. I seem to have, let's take a look at the project. Well, why not? I'll quickly show you if you're not familiar with API 6, the dashboard. So before we go to the GitLab, here we have some open data endpoints defined, and the configuration is relatively simple. It's plugin based, so you can use different plugins. We have limit, we have proxy rewrite, and then it otherwise upstream. Fairly standard reverse proxy configurations. Yeah, let's not go to the CI/CD secrets. We used GitLab. One of the reasons why we use GitLab is that we are very familiar with that. I like it personally quite a lot. And I was talking about the API 6. And we deploy from the staging branch to the staging namespace. Documentation exists, GitLab CI. You need that to be able to run everything. And the routes configuration, for example, is here. So whatever was shown in the UI is reflected in here. And sort of like the development model is that you develop by hand on the UI. Once you fix the configuration, you bring it over here, you deploy it from the CI/CD pipeline, and you don't touch anything. You don't do any actual production changes from the UI. Everything should be under source control. So there you get the accountability, traceability, all these benefits of source control. So basically this one is the same that is in the API 6 dashboard right now. Pretty cool. Then about the trusted marketplace. This was from the project management perspective a little bit painful. Reason being that none of the stakeholders were really willing to take the work. But in the end, we as a contract, we agreed that, okay, we'll do it if you give us a little bit extra money. So we did a budget reallocation for us. This business API ecosystem, so this marketplace has a plugin architecture also. We tried the umbrella version of it. We had some experience with that. Couldn't really make it work. The plugins were outdated while the main component was updated. They didn't fit together. We had a little bit time pressure. So we ended up choosing the IFA-Trust data space plugin, hence giving us the data space capability. And it's basically modern and it has more speed in it. I'll show you the marketplace briefly. This is how it looks like. Let's sign in. Just a moment, I need to prep a little bit. Yeah. There we go. So there are two roles basically: consumer, consuming data, seller of data. We go through Keyrock still, because this IFA-Trust uses Keyrock. Let's hope it works. We had a demo yesterday. It was working yesterday, I swear. So we are in the marketplace and we have this weather observed data put in here. And the IFA-Trust sort of works between organizations. So not between individual identities. It's about trusted organizational access. And for that reason, curling, for example, this data is kind of difficult. So we made a proof of concept landing page for this. So this is the trusted marketplace. Let me log in. Let me try something. So this is the weather observed data. It's an NGSLD data, basically. This is the URL that we'll get the data from, and its type is weather observed. So I can't copy that. Oops. Go away. If we now try to get this weather observed data, let's see what happens. I didn't get it because I don't have the rights to access that data. So short explanation is that there's something called authorization registry. If there's no rule in the authorization registry, I cannot access the data. But if I now go and buy this, and this has full-fledged marketplace capability, basically. Now I should have the possibility to fetch that data. I just have this stupid bar here. Go away bar. Let's go here. And now let's try to get the weather observed. And I do get some data, and it's actually from today. So let's see. Well, that's a big question. Truly. I'd say that this architecture should be considered by there's another project going on, which is DS for SSCC, so data spaces for smart cities and communities. And I understood that they would take this reference architecture forward. Not all the cities do open source, and not all the cities are greenfield cities. So a lot of cities have existing infrastructure, and simply deploying something like, for example, like this, whatever is the ODALA architecture, might not make sense. But if you look at the ODALA architecture, I think it's a good reference, like how modern smart city platform looks like. What does it do? It runs on Kubernetes. It has data space capability. It has connectivity to other systems. A lot of the cities that deploy platforms from the scratch, they focus on themselves, sort of like that. Okay, what data do I have? How do I utilize that data? What does the data mean for me? And after that, they want to like sort of look outside that, okay, how can I cooperate with other cities, or how can I utilize this data that I'm collecting in other contexts? How can the universities use this data? Can we cooperate? What about the companies that are in my city? The other stuff. How can we work together? So I think this is a good architecture, and you can definitely use that as a reference, but you might not have the same starting point also always. The good thing about this architecture is that it's modular, so you can pick. You don't have to take everything. You can just take some of the aspects of this architecture and utilize it. And one of the strengths of this is the broker with the standard API, with the standard data models, and the data spaces are still doing convergence. There are different architectures, but they are converging. So picking up this architecture enables you to converge on the data spaces and the connectors. Like, I hope that answers the question. Let's see, where was I? Okay, so we were talking about the trusted marketplace. Deploying components, briefly about that. So we looked at that already from the GitLab. So basically, whenever this is the deployment model, so main doesn't really have anything. ODALA staging deploys to staging namespace, and basically you run a pipeline. I'm not going to run a pipeline now. Well, why not? When was this done? Well, I'm not sure what this will do, so I'm not going to run a pipeline, but we can look at one of the pipelines. All the secrets should be okay. So this is the merge request. I'm a little pressed on time, so I'm not going to go deeper into this. Okay, so more about the pipelines. Let's talk a little bit about this. There is the click the one. So if we look at the pipeline, what we are basically doing in the I'm jumping around a little bit now. I'm sorry for that. If we look at the, for example, the API 6 configuration, we have the GitLab CI/CD, and in the GitLab CI/CD, we are basically using YAML files templates. So we are substituting values there, and secrets come from the environmental variables, and they get written into the values YAML. And then basically we just run a kubectl apply. So it applies that configuration to the Kubernetes cluster. And there's a lot of these sets. So we just apply all these changes. In here, we have a couple of stages, setup and config. And Profirator is the who manages the Kubernetes cluster. And basically then we just either do staging or production. And then in the runner logs, you can see that what is happening when you run the CI/CD pipeline. So updates, and then it does exactly what the CI/CD is doing. So it's applying those changes, and so what it does is that API 6 has this API. So you can just push configuration through the API for the API 6, and it takes immediate effect. So it creates all these routes. So that's basically the short what is happening in the CI/CD pipe. Source code, yeah, this is one of the big strengths of this. Everything open source. Flyway is hosting like an umbrella repository for the source code, and all the individual stakeholders should link their source codes here. So this is a snapshot of the project. So if you deploy this version or this commit of the component, it should come together as a coherent thing. Okay, so the document that describes the architecture and the components, basically, there's the documentation project. Sorry. So this partially tries to address the documentation, what is happening, but each of the components have their individual documentation. What would be good? Well, we talked about this Logistack, for example. Please. Why is it not? Okay, well, if not that, then this. So each of the components have their individual documentations, because the idea is that you pick and choose a component and they should work as separate entities. Which applications we deploy inside Kube? So Kubernetes, is that what you're asking? Everything. Whatever is in the project runs on top of Kubernetes. I'm not sure if Stefano, if that answers your question, but I'm not sure if I understood it correctly. But ask me a follow-up question if you wish. Yeah, like I said, open source, take a look. If you run into some sort of trouble, you can contact the individual stakeholders who are responsible for the components. You can always ask me. Then some of the lessons learned. This is not technical. This is not technical, this lessons learned stuff at all. Some difficulties, of course, COVID was happening when we were doing this, and communication was difficult. There was only one meeting where all the stakeholders were, and that was Arezzo this year. Whenever we were doing work internally, it was easy because we have the capacity, but whenever we had to do a request over organizational bound, slowed things down, because you never know how fast the guys are answering. One of the saving grace was that we had good spirit and everybody was pushing towards the same goal here. And we had weekly meetings in the technical working group where everybody, not everybody always, but most of the people gathered. We were discussing issues. how to proceed. And we were using the GitLab issue board to just manage the project issues overall. Stakeholder commitment was wavering a little bit at some points, but I understand that because some of the stakeholders run out of budget and it's kind of difficult to commit. And then we extended the project. So that was understandably a big thing here, because if you had planned that, okay, I have a 2-year project, I will plan my resources like this, you burn the resources, suddenly what are you going to do if you don't have, you have already allocated resources to different projects? As Contrasec, we were using the budget maybe conservatively. So in the end, we had resources left and we could allocate more work to this project. And I have to thank the other ODALA stakeholders also in this, because we got funding from them, from their budget, to complete some of this work. And the EU fundings, they have their own peculiarities. I mean, this is my first big EU project like this, and surprisingly big amount of paperwork is required and reporting. I'm not used to that. In industry, you try to streamline everything, keep it simple. As long as things work, you don't care. But here, it's a little bit different. About the component stuff, if you're really serious about running a production system with the proper SLA, you need to have back-to-back contracts. So whoever is providing your component, you need to be able to rely that there are going to be updates, security updates, whatever the promise is. You have to be able to do the risk assessment. This is sometimes tricky with the open source components. Sometimes there are amazing projects, but you never know how they are. You necessarily never know how they are backed up financially. So, you know, it might be a little bit tricky to choose, but I think we made reasonable choices here. X-Road. That's X. I'm a bit fuzzy with the X-Road, but per my understanding, it's like service bus architecture more. To be honest, I can't answer that question. I'm sure that there's a technical way, but does it make sense? I don't know. So the X-Road is being used in Finland. I know that much, and we've been a little bit discussing that. And I know a little bit about the history, that it was proposed to be one of the data spaces prototypes, but it didn't gain traction. That's my understanding. And now there are other alternatives. So I shouldn't see that there shouldn't be any reason why not being able to integrate, but how to actually go about it, and most importantly, why, should dictate the terms. So the short answer is I don't know. Long answer, I may have some idea, but I'm not sure. About the marketplace, yeah, we had to do it quite fast, and there were a couple of false starts, as I said. It's used in this data spaces architecture. I don't know yet. And some of the aspects about the data spaces, the component support and stuff like that is still a little bit up in the air. But I hope that there will be a service provider that backs up them. I really think so. It's a pretty good construct, and this iShare, it's used a lot in the Dutch logistics, which should tell you that it's quite robust. But we are still evaluating personally, like as a company, how that should go about. Now, you have been asking a couple of questions already. I truly appreciate that. We have about 10 minutes, so if you want me to recap something or talk about something, just let me know. Open your mic or ask a question in the chat. All right. Well, I'm not gonna internationally stretch this out. One thing maybe, if you want to get hold of me, I'll type my email address here so you can catch me. So in that case, thanks guys. Thanks for showing up. Thanks for listening. And the ODALA webpage has, I mean, the ODALA project has their web pages and stuff like that. I don't know, Karola or Sara, if you want to say something about that. That's more ask stuff.
No, it's from all of us. Sorry, let me just change my my webcam. So yeah, feel free to visit our website. We also have our GitHub, and you can visit our project and more infos about it. So thank you all for joining us. And I don't know, Illy, if you want to close it and and wish everybody a good week.
Yeah. Yeah, and I mean, this is not the sort of like the end of this. So some of the funded projects, like once the funding dies, it's dead. But I see that this, at least the architecture lives on, and some of the components they live on because the cities are adopting them. So looks nice, looks great.
Yeah,
I'm really happy about this project. It was really nice to work with the other stakeholders. This was a good project. So yeah.
yeah. Thank you, everyone. Thank you again, Ilri, for sharing your knowledge. Hope you have a great week, and we'll see you soon.
All right. Thank you.
Bye, everyone.
Bye bye.